Okay. This is something that we have to know. For exponential, we have to know that e to the power x is always greater than 0. So therefore, to find the domain for ln function, we have to remember this, okay? Whatever expression in the ln, in ln must be more than 0. So this will help us to find the domain for ln function. Do you get me? So that is the true facts about ln that you have to remember. So that means my 5x minus 1, this is the expression in the ln, correct? Its value must always be more than 0 so that it is defined. So therefore, x must be more than 1/5. So you cannot just let this be the answer for part A. You have to tell that, therefore, the domain will be the possible value of x, and x must be a real number, and x must be greater than 1/5. Why domain is important? The reason is because if you know the domain, you will know which region the function is defined. Only defined for x more than 1/5. Okay, and by doing this, it will help us to do part B. So if you look at here, there is no equal sign, correct? So when x equal to something, which means that it is a vertical line. That's why the question part B asks you to state the equation of the vertical asymptote. So therefore, the vertical asymptote is x equal to 1/5. You get it from here. Are you clear? Any question before I go to the next part? So far, so good? Okay, let's go to part C. Find the exact value of the x-intercept. So when we say x-intercept, that means we put the fx equal to 0. That means y equal to 0, you try to look for the value of x. So ln 5x minus 1 equal to 0. So to convert, to find the possible value of x in the ln, you have to convert it to exponential. So whatever in the ln is equal to e to the power of 0. So this is a formula all of us have to remember. If left-hand side is one ln term and right-hand side is a number, then we can convert it to exponential. So what is the value of e to the power of 0? Brian? Is it possible for you to talk, Brian?
Yeah.
Yeah, Brian. What is the value of e to the power of 0?
1.
Yeah, thank you. So it's 1. So my 5x will be equal to 2. So my x will be equal to 2/5. So therefore, the x-intercept is 2 over 5. Okay. Are you okay? So that is how you find, how you state. D. Find the y-intercept. That means you substitute your x equal to 0. So it will be, if you substitute. So actually, I don't have to do this. I can straight away from the domain and explain. Okay, so if you do like that, you will have ln -1. So this is impossible. So therefore you say there isn't a y-intercept. So you have to bear in mind, it doesn't mean that every curve will have the x and the y-intercept. So if I don't want to answer in this way, okay, that would be a better answer by observing, by telling the examiner, say from A, x is greater than 1 over 5. So for x equal to 0, the function is undefined. Therefore, there isn't a y-intercept. Are you clear? So actually, if in the exam, the first answer and the second answer will be a better answer. Better in the sense that the one who do the question, you observe the domain. You don't go by thumb or rule, substitute x equal to 0 to get the y-intercept. So number 2 is a better answer compared to the first answer. You get what I mean? Hello, students, so far, are you okay?
Yes. Yes.
Okay, okay, so let's go to part E. Okay. Before I do part E, we have to look at part E by observing the domain first, okay? So, look, so now I'm going to sketch the axis first. This is a 0. Our domain is x must be more than 1 over 5, correct? And x equal to 1 over 5 is the vertical asymptote. So I put a dotted line. So dotted means the x cannot take that value. So x equal to 1 over 5. So that means my function only defined in this region. So that means if I plot the graph, there is no graph for x less than -5. X less than 5. Are you clear?
Yes.
Okay, good. So I want you to study what happened to x. What happened to y? Okay, my y is equal to ln 5x minus 1. I want to know what happened to y when x approaches 1 over 5 from right. Do you know the meaning of this? So you see, this is the line x equal to 1 over 5. Definitely, it cannot approach from left. Why? Because the domain is more than. So it can approach from the right. You get me? That is the meaning. So that means I'm trying to choose a number of x which is more than 1 over 5, but very close to 1 over 5. So 1 over 5 is approximately 0.2, am I right? So I want to know, as x approaches 1/5 from the right. So what will happen to 5x minus 1? That is called describe. Okay, 5x minus 1. What will happen to 5x minus 1? Who can tell me?
It goes lower and lower.
Yeah, lower and lower to what extent?
To infinity.
Sure. Let's take a number and try. Okay. Let's take a number and try. Okay. Can someone give me a number which is very close to 0.2 but more than 0.2? Oh, that is not. 0.3 is not considered here. Limit, you don't call close to. 0.22 also not.
Oh.
0.21 also not. So I will say 0.20001. Can or not? Isn't it? This is very close. So if I take away, so this is my x. So when I say approach from the right, means the x must be more than 0.2. But very close. Yeah. So I take away 1. What do you think? What do you think the value is? So the answer, I think, is 0.0005. Am I right? Hello? Am I right? So if I take a bit further, so what will happen to 5x minus 1? Can someone give me some idea? What will happen to 5x minus 1? Hello, try. Nothing wrong. You wrong.
Very
negative.
small.
Negative? You see? Okay. Let me jump one step. I jump one step already. Let me try not to jump a step. So you tell me what will happen to 5x. Will approach what?
1.
1. Thank you. Let's talk about 5x first. Instead of 5x minus 1. Maybe you cannot see two steps at a time. So this will be 1. Look, so this will be 1.0005, correct? So it approach 1. Okay, so now you tell me what will happen to 5x minus 1? It will approach
0.
0. But it's not 0, bear in mind. So my 5x here, 5x minus 1, so it will be 1.0005 minus 1. So it will be 0.0005. Am I right? 1, 2, 3, 4. 1 0 less. Correct? So now, if you have your graphic calculator, okay, we know. Okay, so I'm going to teach you how to see without calculator. Okay, we know true facts. Ln 1 is equal to 0. Agree with me?
Yes.
Because e to the power of 0 is 1. All right? Ln e is 1. Agree with me? Because e to the power of 1 is e. Ln any positive number less than 1. Can you please look at your calculator? What do you get? The value, negative or positive? You just put in. 0.0 ln 0.005, you get negative, correct? So as the number approaches 0, the ln of that number will approach negative infinity. You try to key in ln 0.000000001 and see. Isn't it? You got a very negative number. Hello? So this part is the answer for part E. Are you clear? Any question? So the rest all are okay, huh? Okay. So now, I've done the whole question. So now I try to sketch the graph for you to have a look. So the x-intercept is, there's no y-intercept, and the x-intercept is 2/5. Oh, sorry. Two over 5. Yeah, 2/5 here. So the graph will go like that. It will approach infinity. From here, it go down, approach infinity. Because as long as x is less than 2/5, 5x minus 1 will be less than 1. So the ln will be negative. So then the rest, it will be positive. So the graph go like that. So this is my y equal to ln 5x minus 1. Are you okay? So you see the shape of the graph is the inverse, is the reflection of the exponential, correct? Along the line y equal to x. Okay? Any further question? No? So I'm going to set. Okay, what do you want me to repeat? What do you want me to repeat? Can you please let me know what you want me to repeat? You cannot say chair repeat.
The drawing, the last part.
The last part, which last part?
Where you drawn the y is equals to ln 5x minus 1.
Yeah, I'm just sketching the graph. What do you want me to repeat? So I'm just saying the shape is the mirror image of exponential, that's all. Okay, so I'm going to give you another question. You try to do it by yourself, see whether, and this question won't be exactly the same. Yeah, so it will be a bit different, then you see how you go. Can we? Okay, so I'm going to give you another example. Okay, 5 minutes. Okay, so for part A, what we need to do? Whatever in the lawn. This is the expression in the lawn. So if there are two, we have to do two of them. Greater than 0. So negative x should be greater than negative 3. So your x should be smaller than 3 when you divide. If you don't want to do it this way, you also can do it this way. You put the x over, so you read as x less than 3. Nothing wrong with that. So therefore, the domain is equal to x double dot, x is a member of real number, and x is less than 3. Okay, if I don't want to write it this way, still remember there's another way of writing it. Negative infinity, comma, 3 square is a curved bracket. Okay, so up to individual. Okay, so the vertical asymptote is, okay, Dixon, Liu Dixon, can you give me the answer? Dixon, can you reply me?
Hello.
Yeah. Vertical asymptote is?
1.
Why you say 1?
1.
Okay, just now if you have a look at this question, where do we get the answer for vertical asymptote? Dixon?
Yeah.
Okay, so you tell me for this particular question, what is the equation of the vertical asymptote?
So it's 3 of the vertical.
You cannot say it's 3. I won't accept the answer. When you say a vertical straight line, the equation is x equal to something. Horizontal straight line is y equal to something. So Dixon?
Okay. So answer is x equal to 3.
Yes. So when you talk about max, correct, you don't just give me the number. It means nothing. Do you get me? So I will mark you wrong, definitely. Do you get me? So the vertical asymptote is x equal to 3. If you tell me in the exam, vertical asymptote is 3, I will not give you. I can add in a y. So it becomes horizontal. You get me? So it's x equal to 3. Okay, done with part A. Let's go to part B. So find the exact value of the x and the y intercept. Okay, so let's start with the x intercept. We put fx equal to 0. So I have my ln 3 minus x plus 1 equal to 0. Okay. So my ln 3 minus x is equal to -1. Okay. So what should I do the next step? Colin Yun. Colin, what should I do next step?
Hello.
Yes, I can hear you. So please Take an effort to remember how to change from ln to exponential. So this is the formula you're supposed to follow. So Colin, tell me. Your A is 3 minus X. So that is how you compare. So if I have ln 3 minus X equal to -1. So I follow 3 minus X equal to e to the power -1. Are you clear?
Yes.
So please, it's a must to know. If you don't know, the rest of your SAT just gone.
Okay, sorry.
No, don't have to say sorry to me. You say sorry to yourself because
Okay.
the result is yours, not Miss Doe.
Okay.
So that's why a lot of situation whereby the result come out correct. You don't say sorry to teacher, nothing to do with me, because that is your result, not my result. I'm here to make sure that you know what you're supposed to do. So 3 minus X is equal to e to the power -1. So my 3 minus e to the power -1 is the X. Am I right? So therefore, the X-intercept is 3 minus e to the power -1 is 1 over e. So this is definitely more than 0, okay? Positive. Okay, can someone use the graphic scientific calculator and give me the approximate value for this one? Take out your calculator and give me the approximate value for this one, please.
Is it 2.67?
Let me check. Yeah, 2.67. I got
Yeah.
2.63.
No, I was guessing actually.
Okay, you are guessing because 1 divided by 2.7 something, correct? Yeah, so your guessing is very close. So 1 divided by 2, so it's about 0.5. So it's 2.7 something. Yeah, you are right. 2.63. Okay, so that is approximate value. This is exact value. So you are not supposed to give me the answer in red. You are supposed to give me the answer in blue because it's exact. Do you get me? So far, everyone, are you okay? When you see E, when you see ln a number, you don't use the calculator to get the number because the question wants exact value. Like exact value for pi is pi. You use a symbol to represent it. Are you clear? Okay, let's look for our y-intercept. So I put F 0, which is ln 3 plus 1. So this is, therefore, the y-intercept is ln 3 plus 1. Okay, can someone use your scientific calculator to count the approximate value for this one? Yes, just shout out the answer, please. $2.09861, so it's approximately 2.09861. So if 3 significant figure, okay, so you have to give me 2.10, 3 SF. Are you clear? 3 significant figure. All final answer if you round it off to 3 significant figure. So that is how you round off. Yep. So Now we know that our x is less than the domain. That means this function only defined for x less than 3. So I'm going to discuss part C. So if I have the graph, I put the axis. So this is my x equal to 3. So the graph only appear this part. That's why part C, they tell you that as x approaches 3 from the left, this is the left side. So that means I have to find the x value, which is very close to 3, but less than 3. So as x approaches 3 from left, can you tell me what happened to 3 minus x? Can you tell me what happened to 3 minus x? Student?
It becomes closer and closer to 0.
Yeah, so we say approaches 0, correct? Do I need to explain? Do I need to explain? Yes or no? Okay.
Yes, teacher.
Okay, I will try to explain. From the left. So that means I have to choose a x which is less than 3, but very close to 3. Do you get me? So that means, for example, I choose x equal to 2.999999. So that is the meaning of approaches 3 from the left. From the left means it must be less than 3, but very close to 3. You get me? So therefore, my 3 minus 2.999, how many 9? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it will be 0.012345 6. So that's why it will approach 0. Are you clear? Isn't this is very close to 0? Okay. Hello? So far, so good? Okay, good. So then what happened to ln 3 minus x? It will approach what? That means I'm talking about the ln of this number. A number which is less than 1, but is still positive. It will approach?
Negative infinity.
Yeah, negative infinity. Correct? But my function is fx, which is ln 3 minus x plus 1. I owe the bank 1 trillion. You try to help me by giving me 1 ringgit. I still owe a lot or not to the bank? Still owe a lot, correct? So it approached negative infinity. So this is how you describe. So I know that. So from all the information that I have, I know this is vertical asymptote, x equal to 3. And I know this is the x-intercept, which is approximately 2.63. 2.63 should be around here, the x-intercept. 3 minus 1 over e. So as you go, it will approach negative infinity. And this one will go here. So this is the shape of the graph. Okay, you don't have a graphic calculator, you will know. Exponential and ln, the shape of the graph is the inverse. Any further question? I hope you will go through your exponential and natural log. What are the important things about exponential that you must know? What are important things about natural log you must know? So tomorrow I will give you 2 different questions. One is exponential, one is natural log. I will change a bit. Then I will try to test you all the things that we have learned. I'm teaching something that is a bit more than whatever in the textbook, so that when I teach chapter 3, correct, you have this in your mind already, so that I can go faster. So the revision is not just exactly what you have in your year 11. I tap a bit more the idea of limit, so that you know why the graph go in that way. Are you okay? Okay, if there is no further question, thank you, class.
Thank you, Miss. Bye.
Thank you. Thank you.
Bye.
Thank you. Don't say bye.